Okay, well, that's 30 seconds past the hour now. Well,
Very,
ladies and gentlemen, and people who prefer not to be labelled in that way, welcome to the Infrastructure Security Panel. Today, we're going to get a little bit technical, but not too technical, because we understand who our audience is today. But we're going to be talking about basically what happens when the internet moves bits and bytes around, and some of the risks and worries that we as technologists and other stakeholders have with that. So we're going to try to attempt to answer some very basic questions with this panel today. And one is, how secure is the Australian internet infrastructure? Talk about who maintains that, who's responsible for that, and talk about what the current problems and those solutions are that are being proposed for some of those problems. So I have, let's have a look. I have some esteemed colleagues here with me today. You'll see that we have Vanessa Teague, who is the CEO of Thinking Cybersecurity and an adjunct associate professor in the Research School of Computer Science at the Australian National University in Canberra. She's actually located in Melbourne. She was part of a team who, with I think two others, was it Vanessa, who discovered that they could re-identify people, doctors and patients, in a public dump of Medicare and PBS data. So that's a really big kudo for you. We have Matt Tate. Now, you'll probably see Matt Tate in every conference, on every Zoom you'll ever been to, because Matt's, a real personality in our industry. Matt is the managing director of NetThing's Tech Lab. He, for a living for the last 30 years, has been doing ISO certifications and testing of all things ICT, which is good to see. Matt also has a role with HonestyBox, which is an independent internet quality measurement company, and you'll find that Sandy Davey is here today with us as well as a participant who's part of that operation. We have Aftab Siddiqui, who originally hails from Pakistan, has a long career on the industry side and also in what we call the internet community. He's currently with the Internet Society as a senior internet technology manager, and he works on what we call the Mutually Agreed Norms for Routing Security Initiative, or MANAs, or Good Manners, we hope it will be. And he also is deeply involved with internet governance in several roles, especially with the Address Supporting Organisation, Address Council, and he's also chair of the Routing Security Special Interest Group at APNIC. And lastly, we have one of our luminaries of our industry and a very interesting commentator, and that is Associate Professor Mark Gregory. Mark is with the School of Engineering in RMIT University in the Department of Electronic and Telecommunications Engineering. And he has a research and consulting focus in, among other things, telecommunications, network engineering, internet security and privacy, and also something I like to hear about too is technical risk management. So overall, we're going to try to keep this very relevant for end users and for our other multi-stakeholder group today. But what I'll do is I'll invite, first of all, Vanessa to present some of the topic, and then after that we'll have Matt, and then Aftab, and then Mark. Mark actually drew the short straw by not turning up to the prep meeting, so Mark, you're last. So Vanessa, please take it away.
Thanks, Terry. Okay, we all said that we wouldn't have slides, but I'm just going to try and share some of my favorite tabs from my screen. So I'm going first, and I'm going to start by talking a little bit about just the background of the topic for the day. So Terry said he knows the audience. I don't know the audience, so I don't really have a clue how much of what I'm about to say everybody already knows. But let's set the scene. Okay, we're talking about the security of how bits go to the right place on the internet and how to make sure they don't get either dropped or read by somebody who should be either passing them along or not reading them. So I'm going to talk about three different acronyms: DNS, BGP, and TLS. Telstra has been kind enough to furnish us with some educational examples of stuff-ups in the first two of these areas, which just gives us a chance to explain. So I hope you can see my screen. And if you can, I'm just going to have a look at this website, which is protonmail.com. So there's a couple of different things that have to happen right in order for me to type protonmail.com into the address bar of my web browser and for my request to get sent to the right server and Protonmail stuff to come back to me. The first thing that has to happen is that my web browser has to figure out what IP address this name protonmail.com is actually addressed by. And that's DNS, the domain name system. And Telstra back in August had a serious outage with its DNS system, in which, in fact, probably many of you might have experienced, a large number of people found it impossible to visit the websites that they wanted to visit because their computer couldn't figure out what IP address it was supposed to be looking for. It was widely described as an internet outage. Strictly speaking, it's not an internet outage because the internet is still there. It's just that you don't know the correct address of the things you're trying to look at. Initially, Telstra said, help, help, we're under cyber attack, and eventually decided that actually they probably weren't under cyber attack. They were just getting a very large number of requests from people who hadn't been able to figure out what was going on. I'm told that those people who did figure out what was going on and just used Google's DNS server instead or some other DNS server actually worked out fine. You can, just out of curiosity, if you don't already know how to do this, you could always just use the IP address directly if you want. So here's a little thing I prepared earlier. If you happen to know the exact address of where you're going, you don't need the names at all. Right? So DNS can stuff up accidentally, and probably Telstra did. It can also be a deliberate method of trying to grab somebody else's traffic by pretending to, if you maliciously add your IP address to somebody else's name in a DNS server that somebody trusts, you can potentially get someone to come and visit your server instead of the place that they really think they want to go. Okay, so that's the domain name system. Now let's talk about the second aspect, which is routing. So now we've gone, okay, we figured out from the name what IP address we want to look at. Now I've got this string of numbers. How do we figure out how to reach that on the internet? And again, Telstra has provided us with another educational example only yesterday. This is the Border Gateway Protocol, which the latter couple of speakers are going to talk about in much more detail. But the idea is that a internet service provider knows what IP addresses it owns, and it advertises and says, you know, I own such and such and such and such a collection of numbers. And then everybody next to them says, I'm next to somebody who owns such and such a set of numbers. And everybody next to them says, I'm next to somebody who's next to somebody who owns this set of numbers. And thus the information about who's close to where and how to get there propagates out across the internet. This is the Border Gateway Protocol, BGP. That's the second of my 3 acronyms. But obviously, if the advertisement in the first place doesn't come honestly and correctly from somebody who really does own that IP address, then there's trouble. And I know that Aftab is going to talk about this in a fair bit more detail, so I won't talk about a lot of detail about how to secure it, but you can see why if somebody either deliberately or accidentally advertises an IP address that they don't, a collection of IP addresses that they don't really own, they end up grabbing a whole lot of traffic that they shouldn't have. Like all the best kind of computing bugs, this can happen accidentally through a stuff up, or it can happen deliberately as a way of deliberately hijacking somebody else's traffic. So this happened yesterday, apparently, and Telstra advertised a bunch of IP addresses that they didn't really own, or IP address spaces that they didn't really own. And I think they're now blaming it on an unspecified third party and suggesting that it was a stuff up. But of course, the accusation, yeah, good. I'm glad somebody giggled. I can't actually tell exactly who giggled. But the accusation obviously is that perhaps it was done deliberately. And Protonmail in particular, which is this secure email provider I mentioned a few minutes ago, tweeted very loudly and angrily that they were concerned that Telstra was deliberately advertising their IP address space and trying to hijack their traffic. It probably didn't make much difference to the European users who were nearer to the truthful advertisement of the real Protonmail IP addresses, but it might have made a huge difference to the Australians who were trying to access that service through, who were mistakenly directed through Telstra instead of to the real place. So interestingly, Protonmail has said no data was breached. So even though they know that some traffic must have gone the wrong way, they're saying that they're confident that people's private email couldn't be read. Now, Protonmail is an end-to-end encrypted service. I haven't looked in great detail at exactly how it works, and I'm assuming that their belief in the data not being breached is based on their end-to-end encrypted messaging. But let's just leave that aside for a second and talk about how you might, if you were running a relatively ordinary email service, still be potentially confident that you're of the next line of defense if somebody mistakenly advertised your IP address spaces. The next line of defense is a protocol called TLS, which is the third of my 3 acronyms for the day. The TLS protocol is used to protect, both to encrypt traffic across the internet and also to authenticate the place that you're talking to. So that in my web browser, which is Firefox, it's shown with a little lock, but of course in lots of other browsers show it in slightly different ways. Like I think Chrome, for example, warns you when you're not talking through TLS. Okay, so it ought to be that even if a malicious party deliberately hijacks the IP address space, that even if they get the traffic, they still shouldn't be able to trick a visitor into thinking that they are the real Protonmail, because they shouldn't be able to get a certificate that lets them look like a proper TLS server for a domain that they don't really own. Now, unfortunately, like BGP routing, this system is somewhat based on trusting a small number of trusted authorities who are supposed to do a good job of only handing out these kinds of certificates to people who deserve them. So probably if you're just some kind of random person on the internet trying to steal other people's traffic, it's relatively hard. But unfortunately, when we're talking about internet security, part of what we have to think of as a realistic attack scenario is a state-sponsored attacker. So depending on how you think about this, this might either be a government that you don't like, specifically trying to break stuff that you really care about, or it might be a law enforcement authority or intelligence authority from a country that you believe is doing good things. But as a security person, it's the same thing either way, right? So I just wanted to, in my last 2 minutes, read out to you. I've just realized I've not shared my screen properly. Hang on. I'm just going to unshare and then reshare the right thing. I just want to read to you carefully the TOLA legislation. And in particular, no, it doesn't want to share. Okay, I'll just have to read it out to you. Okay, so many of us at the last NetThing discussed in great detail the likely collateral damage or the possible collateral damage from our law enforcement agencies being able to force telecommunications providers to make alterations to their systems as a result of the TOLA legislation and the amendments that were made to the Telecommunications Act as a result. So with this specific example in mind, I went and had a look last night at exactly what the legislation says. Many of you will probably remember that a designated communications provider must not be requested or required to implement or build a systemic weakness or systemic vulnerability into a system, right? But it doesn't say anything about exploiting a systemic weakness or systemic vulnerability that's already there. So I don't see anything there that prohibits them ordering a company like Telstra to advertise fake IP addresses that they don't really own. So that's the first thing. The second thing is it says You're also not to jeopardize the security of any information held by any other person. And that sounds like it would be a good thing, right? Because if they are indeed trying to read Protonmail's traffic, if they have a specific targeted possible criminal in mind, it seems hard to see how they could possibly do that without also compromising the security of all of the other Australians who are also trying to access Protonmail. But unfortunately, if you go and read the very fine detail about it, what it actually says is security compromise in this context means making it easier to access it by an unauthorized third party. So in short, I don't really know. I actually have no idea whether this routing problem is an accidental problem because somebody at Telstra stuffed up, or a deliberate attempt by Australian intelligence or law enforcement to grab Protonmail's traffic and presumably to try to decrypt it somehow. But I don't see anything in TOLA that would make that forbidden. And more importantly, I don't see anything that could allow Australian citizens to have a real discussion about the extent of potential collateral damage. I think this incident proves that what we really, really need is some transparency from our law enforcement and intelligence authorities so that we can get some understanding and some confidence about how often these kinds of problems are a direct consequence of their actions and how often they're just accidental stuff-ups. All right, so I'll conclude there and pass on to the other panelists.
Well, next up we have Matt, but thank you, Vanessa. I think you're going to get some very interesting questions about what you've said today. I'm looking forward to seeing what people raise as issues for civil society. But Matt's probably going to take a slightly different angle on almost exactly the same material, but we're going to be talking about safety, aren't we, Matt?
Yeah, I think there's a couple of things here that have been raised today. I think Jeff Houston, with his things about not wanting to be kept up at night, was a very interesting sort of summary, because he did cover things like digital privacy and anonymity, as well as obviously web security and encryption, and going all the way through to IoT and even cyber warfare. So I think, yeah, following up on Vanessa's points, I think there's some really interesting parts. So there's good things to the internet and there's bad things to the internet. And I think the issue is the transparency and having knowledge of what really is going on, and I think visibility of that. And so you see in these recent two examples of that have come out of the Telstra incidents, the first knee-jerk reaction is it's potentially a cyber incident, and then the next answer is maybe it's someone else playing with systems that maybe shouldn't be played with. And so I think that's one of the interesting things. Something that I thought about when Vanessa was speaking, particularly around DNS, is engineers, especially network engineers, we're very good at fitting square pegs into round holes. So we get given the hole and we get told to work out the most cost-effective, efficient way without impacting too much on consumer experience to come up with a solution. And something that, as most of the industry love and hate us for, we're known for evaluating vendors' internet content filtering technologies. So didn't really want to bring this up here, but Vanessa talking about DNS was really interesting, because we're all aware that DNS poisoning can and does exist. So where an attacker compromises a DNS server or convinces a consumer to set their DNS settings to a compromised server, and then they can essentially redirect the IP address to any site that they want on the internet. So the user thinks that they're going to a legitimate site, they type in the legitimate URL, but in effect, there's a man in the middle harvesting their information and their keystrokes for their own ends. Now, a number of internet service providers, when they're told to filter or block a number of sites, think instead of investing in commercial products or going through the evaluation process and seeing what's out in the field, they can simply poison their own DNSs. So essentially they said, give me a list and we'll we'll put that into our DNS servers, and we'll redirect everyone that tries to go to those IP addresses to a block page or a, you know, cannot access, or even, you know, just the usual 404 page. So that's a solution, but that's a very good example of fitting a square peg in a round hole. And as the articles have alluded to, I mean, no one's ever necessarily going to know the truth. And unfortunately, 9 times out of 10 in my experience, particularly working with government departments and agencies, the truth is far more boring than the reality some people would want to have in their mind. So it could well just be some poor tired network engineer accidentally missed out a 0 in a subnet or something like that, and cut off a significant proportion of their DNS responses, or it could be more significant where there has been a request from a law enforcement agency for access or information or intercept, and unfortunately that's gone wrong. So yeah, I think square peg round hole is something always to bear in mind. So whenever we hear of a cyber incident, unless it's actually verified as an external threat, it may well just be a stuff up by a tired engineer. The other thing coming to mind as well, particularly talking about BGP, while it's a valid technology, it's like all types of automation where you start relying on things. So think of autonomous vehicles and things like that in the age of IoT. Autonomous vehicles would be absolutely perfect if humans didn't exist and the machines were allowed to control all the infrastructure themselves. And even if they did have accidents, no human lives would be put at risk. So this is where we come around to the safety side of it. So BGP, I remember our routing tables at ESA. I mean, this is 21 years ago. We had dial-up internet service. We had 80,000 subscribers across 50 points of presence across Australia. And our routing tables rarely went to the default. So the majority of our IP, obviously v4 in those days, we routed in our Cisco routers, and we could route anywhere we wanted in the world. And of course we could make mistakes, and I'm sure we often did when we were updating those tables at 2 o'clock in the morning, or whenever we could be bothered to find new sites once we found someone had gone through to the default route. But BGP certainly made that a lot easier when we could have, I guess, trusted domains close by, and we could cut down our routes rather than having to default to the global domain name servers and then potentially cost us more on our routing traffic. So I think people aren't being lazy, but they're relying on automated technologies where perhaps they should be a little bit more vigilant. So again, it's a bit of the fitting a square peg in a round hole, but it's also being a bit more aware of what risks your technology poses to you when it either goes wrong or someone asks it to do something that maybe it wasn't intended to do in the first instance. So I think they're always worthwhile things bearing in mind from a technical and engineering perspective. Then the other thing is who's looking at the information. I think that's always been a key thing, particularly when it's information which is intended to be private and confidential, and how do you work through that classification system? And, is all encryption good? Is all encryption bad? There's a number of debates which rage on with the privacy people. So something that's come up over the last couple of years for us in the information security, and particularly the IoT security space, has been this overlay of it's almost in the early days of network security where, that's an IT problem. Like it's not actually about the organizational information and protecting the data and the privacy of that information. It was more about protecting the technology itself. But what's the point in protecting a piece of technology if it doesn't contain any sensitive information, apart from preventing it being used as a vector for an attack or an escalation in services on the other side? So I think what you find is this overlay of the expectation now that security will take care of people's privacy, and that's not necessarily the remit of security. There's risks and policies and procedures, and then the second side is safety. So human lives are now dependent on the safety of technology, and I think for the first time, a direct situations happened in Germany where a hospital was under ransomware attack. So again, a traditional IT attack. It wasn't anything special. They weren't compromising any heart and lung machines or anything like that. It was just a ransomware attack, which caused an ambulance to be diverted to a secondary hospital. Unfortunately, that patient passed away on the way to the hospital. So, you know, there's a direct case attributed of a human losing their life because of a cyber incident. And, you know, as technology advances and the systems advance, humans need to be aware that our safety is now in jeopardy if we don't get security correct. And I think that's one of the biggest things that we're going to see coming up over the few years. You look at institutions or you know, industries like aviation. Obviously, safety is a primary concern for them, not just for their aircraft and their operations, but also for confidence and trust in humans being comfortable to travel on airlines and having a very high safety record. You look at trust in financial institutions and banks. People are expected to deposit their savings into bank accounts and hope that they're still there when they go back the next time to check. And sure, if there was any compromise in that trust, and we now need to start looking at how can we make information systems trustworthy and technologies trustworthy, and trust is a key component and safety is the other key component. So privacy, security, all these things underpin it, but I think we need to change some of our mentality. Coming back to Vanessa's talk, I think, you know, we're often asked, you know, what about these law enforcement agencies? What about these lawful intercepts? What about the Toller Act? You know, at the end of the day, our remit is evaluating vendors' technologies to make sure they live up to the claims that they talk about, and ensuring that they don't necessarily open any potential other risks to organisations as they're planning to implement them, or government departments or agencies. The legislation and the act's far more important, I guess, as underpinning those policies and those procedures. But I'll always come back, you know, you look at our own ASD or even UK's CSG and GCHQ that have been working in signals for decades. I mean, not just, it predates the internet itself, but, you know, their mandate is reveal their secrets and protect our own. So, you know, whatever carriage mechanism that is, whether it's intercepting pigeons and reading the encrypted messages off their ankles, or whether it's intercepting data comms, that's their role, that's their job, that's what they're paid to do. And we need to be aware of it, and hopefully it doesn't impact on us as citizens, but civil society does need to be aware of those factors. I think, you know, it's all good to have, you know, cloaks and smokes and mirrors, but at the end of the day, we need to be aware of that. And it's not just an individual organization's issue, it's a wider community, because the bad guys are always going to use the same techniques to get access to the same information and potentially use that against us. So yeah, I think they're the main things that I sort of picked up on there. Square pegs, round holes, safety and security and privacy. Yeah. So thank you.
No, that's good. Thank you, Matt. Yeah, it's probably going to generate some questions for us in Q&A, especially because we know there are systemic weaknesses in DNS, BGP and other technologies that underlie the infrastructure. And we know that that's being exploited either accidentally or it's been exploited on purpose. So it does lend us to ask that question as a civil society and as also network engineers as to what's going on and what should we be working on, what solutions are available. Now that means I can now lead into Aftab talking about one of these possible solutions. So please, Aftab, tell us.
Hey, thank you, Terry. Sorry. I'm amazing that Vanessa and Matt explained the situation and trying to connect the dots. I just want to read one headline which our very friendly security commentator, Silgreen, published in ZNet last year, in quoting Jeff Houston, of course, who else, a screaming car wreck of internet routing needs a fire brigade. It can't get any better than this. And I was looking for something, and I said, okay, let me stick to this one, because that is actually the right scenario at the moment. And it's not just one fire brigade. Probably we need a lot of them, and maybe an aircraft water bomber as well, alongside a few more things which can help fix the problem. And it's not new, right? So if it has become a newsworthy right now, because everybody is connected to the internet and everybody is using it so much so that without it, your life suddenly at times just stops, right? So it has become newsworthy. Back in 2008, if you can recall, Pakistan Telecom, PTCL, they hijacked YouTube. And that was the first newsworthy incident, right? BBC, CNN, whatever you call it, they all covered it. And at that time, I was heading the network operations of one of the second largest, not the PTCL, network operations of that of an ISP, and we tried to resolve it by talking to them, but it took, like, of course, 2 hours for them to fix it. It was a mistake, but that triggered a lot of debate and say, okay, hold on, there is a problem we need to fix. But the thing is, the problem was there from the very beginning. The glue which connects everyone together, and everyone means there are 70,000 odd networks which connect to each other, creates an internet we use today. They are using one protocol, and that protocol is called BGP, which Vanessa and Matt talked about. And that is more than 30 years old. And if somebody remember, it was designed on a piece of napkin. Well, actually, 2 or 3 pieces of napkin, depending upon how do you read that napkin. So, and it's still, I think it is somewhere in Cisco History Museum. And that was, the idea was that it is going to be between trusted entities. The protocol, the information will be shared between trusted entities. I'm pretty sure we trust each other, right? Right now as well. And we are happy to share all the information without any problem. So the protocol which was designed has inherent problems. And so we had to come up with something either new or a patchwork. So what we did, we came up with several patchworks. And the issue with those patchworks is they are not mandatory. You can do the patchwork, or you can just say, no, I'm not going to do it, right? So the problem starts with the attitude. And the attitude is prevalent in from top to bottom. I can give you a few examples, right? So first thing first, it's not just that you are not getting the internet access. All these hijacks or incidents, I would call it, or possible hijacks, because sometimes you don't know if it was a deliberate attempt or it was just an honest mistake by an engineer. Well, it wasn't an honest anyway. 2 years back, Amazon Route 53, which is the DNS services they provide, it was hijacked. It was a deliberate attempt, because everybody figured out later on, to steal Ether wallet, which is a cryptocurrency, and people lost more than $150,000 in 2 hours. So it has now, so people learned that actually by doing so and so, you can lose money. So more newsworthy. And then yesterday's Telstra event, the first thing people said, okay, Protonmail was not accessible. So my emails were hacked, or somebody read my emails, or things like that. And Vanessa shared all the details that they were quite confident that it never happened. But again, for that many minutes or hours, I was not able to do my business. I was not able to access my emails. I was not able to do several other things, because there were more than 250 prefixes were impacted. It was not just Protonmail. There were like several other organizations ranging from far-fetched places from Ireland and US and Europe. It was all across the globe. It was not very well coordinated. I don't know how they picked it up, but they just picked up random 250 plus prefixes and they started announcing it from their network. But again, as I mentioned, there is an attitude problem, right? And the attitude problem is, let me highlight. So quite recently, 2 months back, Australian government issued a Australian cybersecurity strategy for 2020, right? And if you read that document, it's a very interesting document. And it highlights all the major aspects of the cybersecurity. But the problem I see in that document is everybody is talking about the upper layers of the internet, right? They are trying to resolve ransomware. They're trying to resolve viruses. They're trying to resolve other things which resides on the upper layer, on the application layer, on top of it. But nobody's talking about the infrastructure it is running on, right? So the BGP is not an application there. It's running right beneath that. So that is the base of your infrastructure. And unfortunately, nobody is talking about it. It's a very long document, and you will not find anything addressing that issue. Number one. Number two, then our DFAT department, the Department of Foreign Affairs, they highlighted the UN cyber norms on the cybersecurity and responsible state behavior in the cyberspace, right? There are 11 norms. So they did with our very own SP, Strategic Policy Institute of Australia, they did an amazing round of presentations and awareness campaign, I think a couple of weeks back, to highlight the importance of understanding the ecosystem, number one, and then how you behave in that ecosystem, right? You can't just pinpoint, okay, that is a cyber attack, or that was just a mistake. Okay, let's try to fix that. So you have to be able to differentiate between two. Of course, you have to fix either side. You have to fix in both situations, but you have to be able to identify what was the issue. And please do not, if I'm not sure, of course, I'm not sure if anybody is listening from our government, but please do not do not term the scalability issue as a DDoS, right? If the MyGov website is not accessible, just don't call it that there was a DDoS attack, right? So because then it undermines the cybersecurity issue we all trying to fix, right? Everything is not a DDoS. So, and the third point I would like to address on the attitude is Comms Alliance has done an amazing job in this country, to be fair. Quite recently, they did publish a paper on the scam calling, right? So the people spoofing the phone numbers and how to mitigate that. And there was a consultation process, and I was reading those documents. They did a good job. But unfortunately, it's, again, the underlying infrastructure which is running, that is IP addresses. There's an IP spoofing on the IP address as well. Again, nobody's talking about it, right? Everybody's talking about the things which are, okay, scam calling is a big issue, but IP spoofing is an issue as well as the BGP hijack or the leak. So these are the things we need to understand, that you can't just build a cybersecurity strategy on the upper layers, right? Everybody wants to develop a cybersecurity strategy, but let's start from the basics, right? Let's start from the bottom layers, try to fix that. What I have seen in last 5-6 years, and for quite some time since I have been associated with the Internet Society and leading this manners, which is mutually agreed norms for routing security initiative, is behaviors are changing, right? Specifically in the telco world, in the ISP, in the network operation world, behaviors are changing. It's not like that people are still very stubborn. The telcos are not very stubborn. They do talk to each other. They are trying to resolve issues. I mean, just imagine we are talking about Telstra doing all the bad things in the last couple of months, but the same Telstra is actually rolling out IPv6. I mean, you could never imagine that a couple of years back. And then it's the same Telstra who has actually invested a lot of time in creating route object or authorization, which is a cryptographically signed entity, authority, which gives the world an authority to say you are the rightful owner of these addresses, right? So they implemented it in Australia, right? So this is amazing. But still, if you look at the Australia as a whole, only 20%, less than 20% of the addresses are signed. So remaining 80% are still saying, no, I'm not going to give you any authority to tell you that I am the rightful owner of this resource. So even though it is for free, you don't have to do anything. It just go on a portal supported by APNIC. Just go there and just click. It's still, you're not willing to do that. So that's the behavior part, right? Now the second part comes is when we talk about the responsibility. Responsibility is we are all, I mean, so service provider sector, for instance, right? So service provider sector is, of course, running the infrastructure. So when this incident happened yesterday, the responsibility you saw that they actually mentioned that, oh, it was insignificant issue. That is wrong. If one of my packet hasn't reached its rightful destination, don't call it insignificant. Every packet should reach its destination. That's why it is important that we take that as a responsibility. Stuff up will happen. It's not a foolproof world. Things will happen. Again, I'm going to quote Jeff Houston. I'm just paraphrasing what he said, that BGP, the whole internet is running, is just a magic, right? How everything is connected, how everything is moving, it's just absolutely magic. If you look at what Matt was saying, that if you look at the routing table, it's just amazing how everything is just moving from one direction to another. And if you start looking into this, so many things are broken, but still your internet is working. But I think it is the time that we start bringing in fire brigades one by one and start trying to resolve that issue. It's the more awareness that it's not that you start resolving the issue from the upper layers. I think it's better to start from the lower layers as well, right? And then the last thing on my point is on the attitude again, is when the Bureau of Metallurgy says, we do not accept HTTPS request, is the behavior we need to fix. If you go to https ://bomb.gov.au, it will tell you we do not accept HTTPS. This is the behavior we need to change. And we have to start from the lower layers of the infrastructure rather than starting from the top. So that's my point.
Excellent. Aftab, thank you very much for that. I'm hoping that's actually generated some questions, and I believe you'll have a question there in the Q&A very shortly after we hear from Mark Gregory. Mark, I believe you're our internet person who probably was spawned from the same pod as Jeff Houston at some stage, because you often speak in the same manner and talk around issues in the same way. So I think you're going to probably give us a good summary of all the issues right now and probably raise a few more as well. Thank you very much.
Yes, thanks very much, Terry. Hopefully I'm able to now share my screen quickly. So, yep, I think that's done it. Can everyone see that screen? Oh.
Yep, we're getting some yeses.
So you can see the Word document?
Yes.
Yep.
Okay, sorry. Because what it's done is it's moved Zoom back over to the other screen. It's confused me. Okay. So what I'd like to do very quickly is to try and set the scene in terms of infrastructure security and where we're really at versus what everyone would like us to think we're at. And so if you look at security and privacy, the history of it is that it was not a consideration when the network was first designed and built. When we first created operating systems, when we first created applications, these things were not a consideration. I can remember back in 1982 creating my first worm. Nowadays we call it malware. And we did that because back in those days it was a game. Now, of course, we know that it's a criminal activity, and it is something that has spawned, if you like, these huge international organisations that are carrying out crime on our networks. So we need to put that into context. We need to think about the situation that the history was that the network was not designed with security and privacy in mind, and it hasn't been shifted in that direction at any time since. And so, as I say there in the opening statement, there are no mandated privacy and security standards. The Australian government's telecommunications sector security reforms legislation from a couple of years ago, it's fundamentally flawed. So let's talk about why. Every company in Australia and internationally is on a different path. Are there any specific guides as to what they're to do and how they're to achieve it? There's no visibility of telecommunications security, right? The requirements that are being placed on industry is that they have to commit to being secure. Well, what does that mean? With a car, we can test a car. We can take a car, we can test it, and we can apply security ratings to the car. But today, we can't do that to a network or part of a network because we haven't even thought about how, and government refuses to even consider it. So there's no visibility. Have data leaks and security events decreased? No, they're increasing. Is the problem getting worse? Well, absolutely on a daily basis. Now let's talk about some of the issues. First one is in relation to protocols that we use on the network, and we've already heard discussion about how we try and do secure communications. Well, secure communications is done using a protocol using transport layer security, or TLS. Now, TLS 1.0 and 1.1 is an updated version of the original SSL, and we still call it SSL. We still talk about HTTPS and so forth, and we say it's SSL, but we've really moved on to TLS today. Now, TLS 1.0 and 1.1 are old and they're insecure. If we look at the current protocols, 1.3 and 1.2, 1.3 being a faster version of TLS, many devices that we see in the market don't provide TLS 1.3 or 1.2. Now, just to get an understanding of how important this is, really all of our secure communications today, whether it be over a VPN or a tunnel, accessing a website or email, utilizing voice over IP, all of these things operate using TLS. So we need to put that in perspective. Now, to help things along, Google, Microsoft and Mozilla removed support for TLS 1.0 and 1.1 in March 2020. And so what that meant was that all of a sudden, many people found that they could no longer talk to routers or switches or network devices because they were only set up with TLS 1.0 or 1.1. And so, you know, whilst people became aware that they had a problem with a device with an old protocol that was insecure, what we've seen is that many people have just simply turned off the HTTPS and have gone back to the insecure HTTP. What they should be doing is they should be replacing the device or upgrading the system. But in many cases, that's not happening. And I'll talk a little bit more about, you know, how absurd this situation is in a little bit later. Now, firmware and patching is one of the biggest problems that we have, in that there's no visibility of what firmware and what patches devices should be at. And as you go down through organizations, you go down into small business or you go to home users, and they often have no idea what this means or how to do it. And getting access to firmware and to patches is very difficult. And what we find is that if you look at networks like the NBN, we've still got a lot of people using old DSL firewalls on our network. And many of these old firewalls still utilize TLS 1.0 or 1.1. Now, if someone in their home is hosting a game server or you're using a VPN to access the home, then hackers can get into your home. Now, if you're working from home, then that means the hacker can come into your home, can access your computer or your laptop. Via your computer or laptop, they can then go into your corporate network, and Viola, they've got into companies, they've got into government, they've got into defense. So we have a big problem, and what we're seeing is that the degree of inaction is leaving the infrastructure, the network infrastructure, in an insecure state. Now, other problems that we have is that recently, of course, we've seen a large amount of leaks occurring from major companies. 43 gigabytes of Microsoft operating system was recently leaked onto the network. And what this means is that many companies that are still using Windows XP, for example, hackers are now going through that Windows XP code, looking for weaknesses in Windows XP so that they can get into it. Now, not that Windows XP is really secure, it's not. Microsoft have stated that it's not secure and that it should be replaced. But many companies haven't updated Windows XP, even though it's been out of service now for about a decade. Another problem which we've already heard from, I won't dwell on, is that we have problems when gateways, routers, protocols, devices are not set up correctly, or when mistakes occur and you have BGP loops occurring, or you have BGP route hijacking going on. So these are problems. Now, government regulation, why do we need it? Well, it's obvious that we need it because if we don't have good government regulation, then we have things happening that really shouldn't be happening. And I'll use one example here. I've talked about TLS 1.0 and 1.1. They can be broken into, they can be hacked today. But yet we've still got many companies selling devices that only have TLS 1.0 or 1.1 on those devices. Now, to get around the fact that the devices are insecure, they will often put a little message saying end of life. It's a bit of a joke in the industry. You just put a little message saying this device is end of life. But they're still selling devices that are insecure. I mean, why are they allowed to do this? And the other thing is that we have many devices being sold secondhand that are insecure and unsafe. Now, look, if it was a baby product, then, you know, the ACCC or someone would ban the sale of these things. Yet government refuses to ban the sale of insecure network devices. So you've got to understand, ask the question, why? And I've been asking government to do something about this for 12 years and they haven't been listening. And yet we've got a huge secondhand market in insecure devices. We've also got major companies selling devices that they know are insecure. So where are we at with it all? Well, we know that we've got big problems with the network security. I could go on for hours about problems that are quite visible and easy to see. What we really need is that we need a level of infrastructure security assurance put in place, and that is identifying devices that are not secure and through regulation taking them off the market and forcing companies or individuals to upgrade devices so that they are secure. But on the other hand, we need vendors to be much more forthcoming with systems that allow people to patch and update their devices. We also need people that sell systems to take responsibility for security and privacy. One of the biggest bugbears that I've got is that operating system manufacturers, such as Microsoft, Google, and others, have essentially outsourced the risk by fostering the industry that sell antivirus and anti-malware software. Now, by its very nature, this antivirus, anti-malware industry isn't foolproof, because they're making generic software for different operating systems. And so therefore, it can never match in with that operating system 100%. And so we still get instances of people, even though they've got antivirus or anti-malware, having their operating systems hacked. And this responsibility should be the responsibility of the manufacturer. It should not be a third-party risk mitigation approach. So really, where are we at? Well, my summary is quite simple. We're nowhere. Infrastructure security is something that has been given nothing more than a cursory glance. And what's interesting is that the many billions of dollars spent by government and industry saying that they're working on security and that they're doing things on security, well, the facts just simply prove that they are not spending that money wisely. Thanks very much, Terry. Hopefully that will get the conversation going.
No, that's good. That rounds out the conversation very nicely. I've noticed that we have managed to go over time on the panel speaking, so we have a few questions that have come through on the Q&A, so I'd like to address those. But for our breakout, I think we'll wait until the actual break, which is coming up in approximately 20 minutes time. So I'll encourage our panelists to join the break then and have some one-on-one or one-on-many chats. But we've got two really, really good questions for you. And I think the first one here has come from Sam, and it's one of my favorite topics when it comes to any sort of security issues, especially with the technologies like DNS and BGP. Sam asks, what role do you think blockchain will play in the future preventing these security issues with DNS? It's a good one. Thank you, Sam. So who's going to jump at this one first?
I'm happy to give it a crack first and see what my fellow panelists think, if you like, Terry.
Please do.
So blockchain is a really good technology for providing trust, especially in supply chains. The issue, as we know, with blockchains, even private blockchains or semi-private blockchains in cooperatives, is the technology needed to driven them and to maintain the system. So if your blockchain's short, then it's relatively easy to compromise. If it's long, then it can take a lot of computing power and resources to work. So applying it to a system like DNS, which is, I guess, thrown away the minute it's used, it's very difficult to provide assurances. So you'd need a pretty savvy vendor, or you'd need a pretty savvy standard to be able to deliver assurance using blockchain in DNS transactions, because of the frequency of the transactions and the volume of the transactions. So not saying it isn't impossible, but I think you need a whole lot of the world to come together to come up with some consensus on how that could actually provide the trust and assurance. So it's a good technology for trust, but maybe in DNS it might not necessarily give us the solutions we need without a wholesale chain. And when I think of wholesale changes, I think, when we started running out of V4 addresses and everyone said V6 was the way the world was going to move, and now we're stuck in the middle land. So yeah, it'd be interesting to see.
I saw Mark smile at this question too. Mark, what do you reckon? What's your response on this one?
Garbage in, garbage out, Terry. The problem that you have with blockchain is that what it is designed to do is to provide traceability. It doesn't prevent a malicious actor from spamming, if you like, a system with a whole range of interactions that are just simply garbage. And they can spoof the other side of a blockchain ledger by utilizing a number of past transactions. They can do it sufficiently well that whilst it can be identified, it's difficult to identify. And what the goal is really just simply to have a window of opportunity, a small piece of time when they can confuse systems to give them a way in or to do a particular action. We're still in the infancy of using a system like blockchain, and we need to understand that it's not a panacea to all of our problems, right? If you are putting in details into a DNS or into a gateway that are wrong, as we've seen over the last few efforts where we've had problems with accidental update changes that didn't work at Telstra, if you put garbage in, blockchain's not going to fix anything. It's just simply going to let you know that you've put garbage in, right? The downstream problem's still going to happen, right? So I think we need to understand exactly what blockchain is. Blockchain provides us with a way to trace what's happened, when it happened and how it happened, but it still doesn't fix problems where the underlying systems are not secure, that the information that's being put in may be incorrect, whether it's accidental or not, and it's not instantaneous. That's the other problem that we have, right? Is that malicious actors are working on ways of getting around, how blockchain works.
Yeah, that would be my observation too. One of the strategic disadvantages of blockchain has always been the boundary conditions. That is, what crosses the boundary into the blockchain and exits the blockchain. It's fine. The black box will reproduce exactly what you put into it, but what you put into it's extremely important. And if you don't trust that or know it's valid in the first place, blockchain doesn't solve your problem for you. Okay, Aftab, I have a specific question from Keith Bestgrove. He is asking who should take the responsibility for addressing the weaknesses in the infrastructure and how should they go about it? So I'm assuming this is particularly aimed at routing in general, but maybe some of the other panelists can chime in on other areas as well. But BGP, how do we fix it?
So you don't have a magic bullet for that, to be fair, right? So there are multiple steps you have to take to make sure that you are actually protecting the infrastructure you are running, and of course the infrastructure you are connected to, which is the internet, right? So there are certain steps, there are certain best practices, and the responsibility is with everyone running the infrastructure. So it goes to Telstra, Optus, Vocus, whoever. No matter how big or small you are responsible for making those decisions, right? It's, as I said, it's everything is based on trust, but trust comes with certain rules and regulations, and you put those rules or regulation on your trust agreement, and that trust agreement is the peering between two networks, and that peering infrastructure and the peering and the connectivity between those two networks, you put in place certain filterings. I mean, you are most welcome to come and see the network, but don't send any garbage in. Don't throw any garbage here. And by saying that, I'm not gonna send any garbage to you, but make sure that you filter it out as well, just in case by mistake I send something to you, right? And that's how we have been dealing with this issue for last many years, and that's how internet is working. The problem occurs when people don't follow those norms, what we call it, and the best practices. And they just assume that, okay, this is how it's gonna be connected, and just leave it or forget about it, and everything will be working as it is. So who's responsible? For example, the case just we saw yesterday from Telstra. Of course, Telstra is responsible, right? But there should be a norm. There should be, as I said, there should be a guiding principle in Australia saying if something happens, there should be a responsible investigation, and the community should be updated that what happened and how it happened and what are you doing to fix that issue. That is the responsibility part. You can't fix it with the legislation. No, it's impossible, right? The moment you put a legislation on top of it, there will be so many, like there will be a 200-page document explaining what actually happened, discussing nothing which actually happened. So there will be a preface, there will be a foreword, there will be a conclusion, there will be like a long list of references on it, and nothing conclusive out of it. So there's no point putting a big stone of registration on it. Just make sure that we all behave like responsible people and since we have been doing it for a very long time, it's not new. The protocol is not new. The fixes which are there are not new. I mean, we call RPKI as the new infrastructure. Well, it's been more than 10 years since we started working on it, right? Okay, now it's getting more traction. People are deploying it. People are doing the better things. As I said, behaviors are changing, but we are not there yet. The responsibility lies at the end of the day with the network operator. And as a community, we have to do much better.
Indeed. I have a good question here from Teresa Corbin. Hello, Teresa. Has the recent work by the ACMA on scam technology are different for consumers, and will the upcoming Communications Alliance industry code help at all? That might be one for Matt, given your involvement there. Do we know if that industry code will be helpful, especially in the infrastructure context?
Yeah, well, I think I can't really speak on ACMA's behalf, but obviously from Comms Alliance perspective, it is difficult to get, as you're well aware, Terry, a number of CSPs together and get them to come to a consensus about what should and shouldn't be done, particularly, I think, when they have to share information between each other for a number of reasons. And it's even harder when you need to come together with government departments and agencies and have that information sharing. So I think all that said and considered, it's been acknowledged that obviously scam calls, scam messaging is a big issue that plagues a number of, I guess, the public and people with technology. So I think to some degree it does address the code, and it's good that the industry has come together relatively unanimously to support that. Whether it goes far enough in terms of educating or pushing it out, it's yet to be seen. But I think at least it steps in the right direction, and it's currently with the ACMA. So with any luck, they will get back to us on it. And I know that, thank you, Teresa, ACAN has forwarded a number of comments around that, and they're very constructive, and you know, I think they're worthy of consideration, particularly the proactivity in ensuring consumers are aware of what protections and reporting mechanisms should be available to them to get on top of it sooner rather than later. It is a blight. You know, it goes back to the days of spam. I think, you know, people find different vectors for you know, getting in contact with their targets, and you know, this is just one of them which has come up over the years. And again, looking for solutions that are readily implemented across industry that people can agree to is not necessarily an easy task, but I think it's something that Comms Alliance has managed to do within that code.
Cool. Yeah, I've got 2 more questions here in the list, but I think we might only have room for one. But RM's put a very interesting question to the panel, which I'll leave open to any one of you. How does the advertising and surveillance capitalism erode this infrastructure, i.e. the issues between nowhere land, IPv4, IPv6 obviously benefits this model. What are the incentives to fix this? So it's a very interesting question. The idea here is, you know, we have that layer, that application layer, and they want something out of the infrastructure, but are they actually helping or hindering us in securing that infrastructure? So it's a very good question from RM. So do I have a hands up for a volunteer to take that one on? Well, Mark, are you putting your hand up? Or is it just a beard stroke?
I think Vanessa probably has some good thoughts on this one. I mean, it does come down to those, I guess the owners of the platforms more than anything. And I think we heard this morning following the keynote, Digital Rights Australia, talking about those groups where, you know, they've set up transparency. You know, I love it when we hear vendors say that they've set up an independent laboratory to evaluate their own products and release details about that. I think they call them transparency centers now. And even if they were set up with the best intent, you can hardly call it independent. And so whenever we get a message across our labs table saying, oh, we're about to use XYZ's transparency lab to perform an evaluation, I say, well, how about you send ABC, DEF, and GHI's products to them as well to put through the same paces and see whether they can give you an independent report on that, and also tell me how ABC, DEF, and GHI are going to be happy about putting their products through, that lab's paces. And so I think it's the same thing when you hear, the platforms talking about looking after privacy and protecting information and not using it for advertising or sharing it when, the whole infrastructure is based and revenue models are based on that. It's interesting, but I'm sure, Vanessa, I'm going to handball this one straight to you. So over to you. It'll be interesting to hear.
Well, I'm not sure I have anything very profound to say, so I completely agree with exactly what you just said. I'm not sure it's an infrastructure security issue, right? I assume that these people would like the infrastructure layer to be as secure as the rest of us would, but they're certainly the prime perpetrators in terms of peeping into other people's devices and spying on where other people are. And so the layer that they build, the kind of surveillance layer that they build, puts all of us at risk. Nothing to do with BGP routing, but just this kind of constant grabbing of information about everybody all of the time, which has all kinds of implications for making us vulnerable to everything from scammers to election manipulators. I don't know what we do about it, unfortunately. I can't think of a good incentive to fix it. I wish there was a good incentive to fix it, but I don't see it being fixed anytime soon, sadly.
Yeah, I think overall, as far as the infrastructure security issues are concerned, it's very much like anything else in internet governance. We have a large number of stakeholders. We have government, we have vendors, we have operators. They're all competing against each other on certain issues, and they're allies on other issues. So I think on infrastructure security, it's probably one of the few areas in governance where we can get the most amount of people in the same room to agree that it needs to be done. I don't think anyone out there, except for malactors, want an infrastructure that is insecure. They don't want insecure electricity networks. They don't want insecure water networks. And I think at this stage in society, given it's the 21st century, we don't want an insecure internet. We want an internet that is reliable and delivers and does the right thing by all of us as a society, and also for governments and for everyone else who has a stakeholding in the situation. So thank you, Matt, Aftab, Vanessa, Mark. I think this has been very educational. It definitely went in directions I wasn't expecting, which is great. And I'm very, very grateful for you guys committing your time today and also attending the conference today as well. So thank you very much. Over to you, Melody.
Thank you, Terry, and thank you to our awesome speakers. It sounds like there might be some space. We're actually going to break out earlier. So if everyone is happy to join in our social room, so our break time social room, you can continue the conversation with our speakers and also continue to ask them questions as well. So do join the Zoom meeting room. The link has just been dropped in the chat. So click on the link and it will be a little bit more social. You will be able to see each other and interact in the meeting room. So if you enjoyed that panel, how about sharing a tweet as well using the hashtag NetThing or NetThing 2020 to share your thoughts, or even to share links that might be related to this panel. So right now we will have a 15-minute break. During this break, as I mentioned, we will open the Zoom room. So speakers, I do invite you to also join that room. We might have some participants who have further questions for you. So just click the link in the chat. Last but not least, I will see you back here at 2:30 p.m. Australian Eastern Standard Time for our next panel on Gaming Our Future, Emerging Technology and the Future of Internet in Australia. So that's really exciting, and I hope to see you in 15 minutes.